As we approach the year 2050, the average global temperature is expected to rise by an additional 1.5 degrees Celsius due to climate change, greatly disrupting marine ecosystems and leading to a higher frequency of toxic algae blooms. As temperatures continue to rise, the conditions become more favorable for blooms to form, so their frequency will only increase as time goes on. Our inspiration to create the BayProtector system came from a class visit to our local bay, where we learned about the pressing problem of nutrient pollution. When excessive amounts of nitrogen are released into waterways, usually in the form of agricultural and residential runoff, it causes eutrophication, which leads to algal blooms. When eutrophication combines with the warm water temperatures caused by climate change, the results are large and uncontrollable blooms that destroy marine habitats and toxify drinking water. The existing solutions to this growing problem are costly and often require lots of new infrastructure. With this in mind, our team challenged itself with finding a solution that was compact, inexpensive, and versatile. We looked to nature to achieve this. After some research, we came upon a classic example of absorption in the human body, the villi. Villi are tiny structures protruding from the inner walls of the small intestine that absorb nutrients and allow them to enter the bloodstream. Their finger-like structure increases surface area, optimizing nutrient absorption. With this principle in mind, we sought to create a device that emulated the villi in absorbing nitrogen from stormwater. Our initial prototype seemed promising, but it failed in allowing water traveling through the center to interact with the villi. In our redesign, we looked again to the small intestine to solve this problem, finding that the overall shape of the small intestine further increased absorption surface area. We used this idea to create walls on which we placed the villi, which would dictate flow just like the meandering structure of the small intestine. Finally, we tested our design. The water that had passed through the design contained over 90% less nitrogen than the original stormwater. In the future, we'd like to make our design target phosphorus, another limiting nutrient. In a world with increasing temperatures, the BayProtector will help keep our waterways healthy for generations to come.